The Boeing Starliner was meant to stand as one of NASA's proudest accomplishments, an advanced spacecraft designed to carry American astronauts into orbit, restoring independence in human spaceflight without the need for foreign support. When it was announced, it was praised as the next milestone in space travel, set to rival SpaceX's Crew Dragon. Yet instead of becoming a celebrated success, Starliner grew notorious for repeated troubles. Its test flights underperformed, its schedule dragged out over years, and its fixes often looked more like patches than progress. A mission that was supposed to highlight America's leadership in space gradually turned into a story of delays, setbacks, and heavy financial strain. So what exactly caused this downfall? How could a company as seasoned and trusted as Boeing, with decades of experience building airplanes and rockets, stumble so much on a spacecraft that wasn't expected to be groundbreaking? And more importantly, what's the deeper truth behind why Starliner could never live up to the vision NASA and the public once believed in? This is the account of a program stuck between bold ambitions and hard realities, where reputation, politics, and flawed execution collided to create one of the most striking cautionary examples in today's space industry. For decades, Boeing wasn't just another aerospace company. It was the face of American engineering strength. Its aircraft carried millions across the globe, while its rockets and spacecraft contributed to NASA's most iconic missions. From the early Mercury capsules to the mighty Saturn rockets, Boeing and its partners had their fingerprints on the foundations of human space exploration. To most, the name Boeing symbolized reliability, tradition, and technical mastery. When NASA announced the Commercial Crew Program, many saw Boeing as the obvious frontrunner. With its unmatched history and strong ties to government contracts, the company appeared almost destined to succeed. Compared to the relatively new and risk-taking SpaceX, Boeing was viewed as the safe bet, the one organization that could deliver a crew vehicle without drama. After all, this was the company that helped put astronauts on the moon. But legacy can be a double-edged sword. The very weight of Boeing's history created expectations that were difficult to live up to in a new era of leaner budgets, faster innovation, and private competition. Where SpaceX thrived by moving quickly and taking calculated risks, Boeing relied on its long-established methods, approaches that, in this case, were not enough to meet the challenges ahead. After the retirement of the Space Shuttle in 2011, NASA faced a serious gap. For the first time in decades, the United States had no direct way to send its astronauts into orbit. Every trip to the International Space Station depended on buying seats aboard Russia's Soyuz spacecraft, a costly arrangement that clashed with America's long-standing goal of self-reliance in spaceflight. The agency needed a solution, and fast. That solution came in the form of the Commercial Crew Program, an ambitious initiative to fund private companies in designing, building, and operating new crew vehicles. Instead of NASA itself constructing the spacecraft, the agency would act as a partner and customer, awarding contracts to companies that could meet safety, performance, and cost requirements. This marked a major shift in how America approached human spaceflight, one that opened the door for fresh innovation. Two big names quickly rose to the top: SpaceX, with its bold and untraditional style, and Boeing, with its decades of government-backed experience. Each received large contracts to build a spacecraft capable of ferrying astronauts safely to the ISS. For Boeing, the Starliner was not just a business opportunity. It was a chance to prove that the company's legacy could adapt to a new era. For NASA, it represented a safeguard. If one company stumbled, the other would still provide America with access to orbit. At its core, the Starliner was built with a simple, practical goal: to provide a reliable spacecraft for routine trips to the International Space Station. The design followed a capsule style, drawing on lessons from earlier programs, but updating them with modern features. It could carry up to 7 passengers, though in most missions it would transport 4 astronauts along with their supplies. The spacecraft was meant to be reusable, capable of flying as many as 10 times with only about 6 months needed between missions. Its landing system also set it apart. Unlike SpaceX's ocean splashdowns, Starliner would return to solid ground, using parachutes and airbags to touch down safely in the desert. For NASA, this meant easier recovery and quicker turnaround. To launch the capsule, Boeing partnered with United Launch Alliance, choosing the Atlas V rocket as its carrier. While the Atlas had a strong track record of success, pairing it with a new spacecraft added extra layers of complexity. Still, at the time, Starliner was presented as a straightforward, dependable solution, a spacecraft that wouldn't reinvent the wheel, but would give NASA the independence it had lost after the shuttle program. In December 2019, Starliner was finally ready for its big test, the orbital flight test, known as OFT-1. This uncrewed mission was supposed to demonstrate that the spacecraft could launch, reach orbit, dock with the International Space Station, and then return safely to Earth. Success here would have paved the way for astronauts to climb aboard in the near future. But almost immediately after liftoff, things went wrong. A timing error in the spacecraft's internal clock caused the vehicle to fire its engines at the wrong time, placing it in the wrong orbit. Instead of heading toward the station, Starliner found itself stranded too far away to complete the docking. Engineers on the ground scrambled to salvage the mission, managing to bring the spacecraft back down safely. But the key objectives were missed. Investigations later revealed not just one, but multiple software and communication issues. Problems serious enough that, had astronauts been on board, the outcome might have been dangerous. What was meant to be a triumphant debut instead became a warning sign. Boeing, once considered the safe bet, now had to prove that it could fix its mistakes and deliver on the trust NASA had placed in it. After the troubles of OFT-1, Boeing had no choice but to try again. NASA required the company to repeat the uncrewed mission at its own expense, meaning no additional government funds would cover the redo. This marked the beginning of years of setbacks, as the second attempt, OFT-2, was repeatedly postponed due to technical problems, software reviews, and hardware concerns. Originally scheduled for 2020, the launch slipped into 2021, only to be delayed again when engineers discovered valve issues in the propulsion system. Months stretched into years, with Boeing constantly working to correct flaws that seemed to surface faster than they could be fixed. Each new problem raised doubts, not only about the spacecraft's readiness, but about the company's ability to deliver on its promises. Finally, in May 2022, OFT-2 launched successfully. This time, Starliner did reach the International Space Station and later returned safely to Earth. While the achievement was an important milestone, the years of delays had already taken their toll. By then, SpaceX had completed multiple crewed missions, making Boeing's hard-fought progress look like a game of catch-up rather than leadership. On top of that, Starliner was designed to operate fully autonomously, while still allowing manual overrides by a trained pilot. Combining manual control with automated systems required sophisticated software, precise timing, and fault-tolerant hardware. Every test flight revealed just how delicate this balance was, and how even minor errors could cascade into mission-threatening problems. Boeing's Starliner program wasn't just a technical challenge, it was a financial one as well. The company initially received billions in funding through NASA's Commercial Crew Program, but these were fixed-price contracts, meaning every dollar spent above the budget came directly out of Boeing's profit margin. Unlike the old cost-plus contracts, where expenses could be billed to the government, Boeing now had to manage funds carefully or risk losing money on each delay. Despite receiving $4.2 billion to develop Starliner, the program faced repeated overruns. Hardware malfunctions, software rewrites, and extended testing all contributed to rising costs. Each launch scrub or test failure added months of additional work, driving up expenses further. Meanwhile, SpaceX, working with lower initial funding, moved faster and more cost-effectively, highlighting the financial pressures Boeing faced in comparison. The result was a company caught between two extremes, needing to maintain technical excellence while staying within a fixed budget. Every misstep, no matter how small, had immediate financial consequences. For Boeing, the money was no longer just a resource. It became a critical factor shaping decisions, timelines, and risk assessments throughout the Starliner program. Boeing's struggles with Starliner weren't purely technical. They were also deeply rooted in corporate culture. Once known as an engineer-driven company where safety and design were top priorities, Boeing had shifted over the years to a culture increasingly focused on profits and shareholders. This change accelerated after the 1997 merger with McDonnell Douglas, which brought new management philosophies that sometimes clashed with Boeing's original approach. Instead of engineers leading decision-making, cost-cutting became a major priority. Safety remained important, but choices were increasingly filtered through a financial lens. For a project as complex as Starliner, this cultural shift had real consequences. Problems that could have been addressed early were sometimes overlooked, communication between departments became strained, and critical technical issues were not always shared with astronauts or even the engineers responsible for testing. The result was a company caught between two identities, one steeped in aerospace excellence, the other driven by corporate imperatives. When technical challenges arose, this tension slowed problem-solving, delayed launches, and contributed to the perception that Boeing's once trusted reputation might not be enough to guarantee success in the modern era of space exploration. NASA played a critical role in guiding the Starliner program, but its oversight was not without challenges. The agency had to balance trust in Boeing's decades-long experience with the reality that this was a completely new spacecraft under a modern commercial contract. Engineers, managers, and astronauts worked together to monitor every step of development, from design reviews to launch simulations, while also managing risks that could affect the crew and mission. To ensure safety, NASA assigned teams of experienced astronauts to act as consultants. These astronauts provided feedback on systems, procedures, and potential hazards, but sometimes found Boeing's engineers resistant or slow to respond. Compared to SpaceX, which actively incorporated astronaut feedback, Boeing's approach often seemed more hierarchical and less collaborative. Even with these challenges, NASA continued to provide resources, funding, and technical expertise. The agency's oversight ensured that each flight test met minimum safety standards, but it could not fully compensate for the organizational and engineering issues Boeing faced. Ultimately, NASA's role highlighted a critical tension: how to hold a legacy aerospace company accountable while giving it the space to innovate and deliver on a commercial crew contract. The story of Starliner captured the public's attention, but not in the way Boeing had hoped. Media outlets focused on delays, software glitches, and repeated scrubs, portraying the program as a cautionary tale of mismanagement and missed deadlines. Headlines highlighted astronaut stranding, technical failures, and competition with SpaceX, often amplifying fears that Boeing had lost its edge in human spaceflight. Public perception was shaped not only by these setbacks, but also by the contrast with Crew Dragon, which was seen as agile, innovative, and successful in completing its missions. Social media and online forums dissected every failure, sometimes inflating risks, while fans of NASA's astronauts worried about the safety of Starliner crews. Despite the negative coverage, the reality was far less dramatic. Astronauts remained safe, protocols were followed, and NASA had contingency plans in place. Still, the repeated delays and technical hiccups gave the impression that Boeing was struggling to meet expectations. In the court of public opinion, reputation mattered as much as performance, and Starliner's image was slowly becoming one of a high-profile, underperforming project. By the summer of 2024, Starliner was finally ready to carry humans. Butch Wilmore and Sita Sunny Williams, two of NASA's most seasoned astronauts, were on board the capsule they had watched evolve for years. Both were combat veterans and highly experienced in space operations, making them ideal candidates for a test flight on a spacecraft with a history of technical uncertainty. As the mission began, the crew conducted extensive shakedown tests, checking both automated and manual control systems. Early in the mission, several RCS thrusters began underperforming, triggering alerts and forcing engineers on the ground to troubleshoot in real time. Helium leaks in the pressurization system added further complications, reducing the efficiency of the engines and threatening maneuverability. For an hour, Starliner hovered just outside the safe docking envelope with the ISS, while engineers devised a solution. Using remote commands, the team was able to reactivate some of the disabled thrusters, allowing a successful docking. Even with these challenges, the astronauts remained calm and professional, executing tasks, conducting experiments, and communicating with mission control. The mission demonstrated both the spacecraft's resilience and the astronauts' ability to handle unpredictable situations in orbit. The issues with Starliner's thrusters were more complicated than initially realized. Each engine cluster relied on pressurized helium to feed the hypergolic propellants into the combustion chamber. Helium's light, inert properties made it ideal for this task, but its tendency to escape containment introduced a persistent risk of pressure loss. During the 2024 mission, repeated firing of the RCS thrusters led to gradual degradation, prompting the spacecraft's software to mark 5 of them as unusable. Most of the affected nozzles were aft-facing, directly impacting the ability to maneuver the capsule safely. Even small variations in thrust could confuse the onboard computer, which automatically shut down engines to prevent further errors. Engineers on the ground worked tirelessly to understand these anomalies, running multiple hot fire tests with the same thrusters once Starliner returned. While they were able to replicate some issues, the exact root cause remained elusive. A combination of valve expansion, seal deformation, and pressure fluctuations seemed to play a role, but the inconsistent nature of the failures made it impossible to predict future behavior with certainty. The uncertainty surrounding Starliner's thrusters created significant challenges for Boeing. Even as the capsule prepared for autonomous return, engineers could not guarantee safe reentry. The service module, which housed the problematic systems, would burn up upon reentry, leaving Boeing with no physical hardware to examine once the spacecraft returned. This limited their ability to fully diagnose the failures before future missions. For Boeing, the stakes were both technical and financial. The company had already spent the bulk of its contract funds, leaving little room for profit. Every delay and setback meant additional expenses and extended timelines. In parallel, SpaceX had established itself as a reliable alternative for NASA, making Boeing's delays more damaging to its reputation than ever. Ultimately, Boeing faced a difficult choice: cancel the Starliner program and accept the loss of billions, or continue investing in a spacecraft that still had unknown risks but could eventually fulfill its obligations. Both options carried potential losses, and the long-term viability of Starliner remained uncertain. The situation underscored the challenges of modern commercial spaceflight, where technical excellence, corporate strategy, and financial risk intersect in complex and unpredictable ways. The Starliner saga highlights just how difficult spaceflight really is. Rockets are complex. Astronauts face extreme challenges, and even experienced aerospace companies can struggle to deliver on high-stakes contracts. The failures of Starliner reveal the importance of putting engineers and technical expertise at the center of decision-making, rather than prioritizing profits or shareholders above safety and design. Looking ahead, Boeing still believes in Starliner's potential. Assuming the capsule returns safely, the company will analyze data, adjust systems, and prepare for another attempt. NASA remains committed to sending astronauts aboard Starliner in the long term, though the timeline is uncertain. The lessons are clear: collaboration, thorough testing, and putting human and technical priorities first are essential to succeed in commercial space exploration. While Starliner has faced repeated setbacks, the broader goal of returning to a robust era of human spaceflight remains. For Boeing, NASA, and the astronauts, the story is far from over. It's a reminder that space is unforgiving, but progress is always possible when expertise and persistence guide the way.